Okay, so I know that there was a lot of confusion with what I posted the other day. The website wasn't as easy to use. Maybe if some of you used Desmos, and only 3 of all of you completed the form. So let me go through this for exactly what I need you to understand from here. Okay, so a quadratic function, we've studied this. This is our standard form. Wrong one. So standard form for our quadratic. ax squared plus bx plus c, where a, b, and c are real numbers. Okay, so a, b, and c have to be numbers, and that's very important, and we'll look at examples of that. Okay, so the website did not seem to work, but what I did is I used Desmos and I graphed 3 different functions. In red is y is equal to x squared. In blue, y is equal to 2x squared. And in green is the graph of y is equal to 10x squared. So one of the questions that I ask you to answer on the form is describe what happens to the graph as a gets bigger. I put 3 examples on here, but please, I encourage you, go back to Desmos and let a be any number greater than 0 and look to see if you were to graph it on your own, what's happening. Okay, and I do ask you to write that response as you're in the form. So I want to know, as a gets larger, the graph is, and you're going to sort of fill in the blank there. All right, did the same thing for the next prompt. Describe what happens to the graph when a is negative. So in red is x squared. In green is negative x squared. In blue is negative 2x squared. So when a is less than 0, that's another question that I have you answer on the form. What happens to the graph when a is equal to 0? I want you to use vocabulary. I want you to use words like reflect. I want you to use words like your x-axis or maybe your y-axis. So use vocabulary that's going to be important for describing functions later on. All right, for the graphs given below, look at the relationship between the value of c and the y-intercept. So what's c? Well, standard form is ax squared plus bx plus c. So what's c called? C is our constant term. Okay, so notice each of these functions, I have a value that b is equal to 0. And I just did that because that's what the worksheet had b equal to. But again, I encourage you to go back to Desmos and graph something like negative 3x squared plus 2x plus 1. Okay, and answer the same question. What's the relationship between this value and the y-intercept? Okay, so in red is the graph of x squared plus 2. In green is the graph of negative x squared plus 10. So there we have that negative in there. And in green is the graph of x squared minus 4. Now, maybe you're asking me, but Mrs. Foreman, what is a y-intercept? Okay, so if we're using, oh, my screen doesn't work over there. If we're using academic vocabulary, your y-intercept is the point where the graph crosses the y-axis. Okay, so the y-intercept is the point where the graph crosses the y-axis. And if you've forgotten, let me remind you, your y-axis goes up and down, that's your vertical axis. Your x-axis moves left to right, that's your horizontal axis. Okay, so now let's look at some examples. So again, these 3 questions I ask you to answer in the Microsoft form that I prompt you to complete at the end of this video, and some of you have completed it, and I would encourage you to do it again. Find the values of a, b, and c. So here's my quadratic. Y equals x squared minus 3x minus 4. y equals ax squared plus bx plus c. A, B, and C are numbers. I cannot stress that enough. So A, B, C. I'm going to start with C. C is my constant term. That's the value that doesn't have a variable with it. So there's my -4. B is the coefficient to my x. What number is x being multiplied by? -3. A is the coefficient to x squared. What number is x squared being multiplied by? Well, remember, when there's no number there, we know it to be a 1, because 1 times anything doesn't change the value. So A is equal to 1. They have to be numbers. Okay, next I'm going to factor. All right, so when A is equal to 1, we learned our factoring. We need two numbers that multiply to -4 and at the same time add to -3. And where do these values come from? They are exact values for B and C. So two numbers that multiply to -4 and at the same time add to -3. Okay, so, oh, that's my highlighter. Factors of -4. So I could do -2 and +2, but -2 plus 2 does not equal -3. So that's not going to work. Okay, so let me try. 4 times -1 is -4, but 4 plus -1 is not -3. So I'm on the right track. I just need to change my signs. -4 times 1 is -4. -4 plus 1 is -3. Okay, great. So what do I do with my factors? X minus 4 times x plus 1. So that's my factored form. Okay, next, the x and y intercepts. And I know that this was a very common question from everyone. I kept the factored form at the top. The next two questions ask for the x and y intercepts. I start with the y-intercept because it's easier mathematically. To find a y-intercept, you set x equal to 0 and solve for y. Remember, a y-intercept is the point where the graph crosses the y-axis. So if I plot on the y-axis, any ordered pair will always have an x-coordinate of 0 and then whatever the y value would be. So mathematically, that's what we do. So y equals, wherever I see an x, I'm going to replace it with 0. Okay, so wherever I see an x, I'm literally replacing it with the value of 0. So y equals 0 squared is 0. -3 times 0 is 0. And then the only thing I'm left with is -4 because it didn't have an x. So what does this become? Y is equal to -4. So what's my y-intercept? It's the ordered pair where x is equal to 0 and y had a value of -4. Okay, so intercepts are points. They belong as ordered pairs. All right, so exact same problem. Now find the x-intercepts. Okay, so an x-intercept is a point where the graph crosses over the x-axis. So no matter where I am on the x-axis, my y value is always equal to 0, and then my x value is whatever the point is where the graph would cross over. So to find my x-intercept, I always have to be solving for x. What do the directions say? Set y equal to 0 and solve for x. So now into my factored form, wherever I see y, I'm going to replace it with 0. Okay, well this is new. So let's think about this, guys. How do I multiply to 0? I multiply to 0 when one value is equal to 0, one factor. Why? Well, because 0 times anything will give me 0. So it doesn't matter where the 0 is, as long as one of my factors is equal to 0, my whole product is going to be 0. So imagine multiplying 3 numbers. As long as one of those numbers is 0, my entire product becomes 0. So it's very important that you're excellent with factoring. Once you factor, you take each individual factor. So remember, our factors are things that are being multiplied. So here's my first factor. So I'm going to take my first factor, which is x minus 4, and set it equal to 0. Adding 4 to both sides, x is equal to 4. That's my first x-intercept. So as an ordered pair, my x value is 4, and I got that by setting y equal to 0. Well, okay, x minus 4 is a factor, but how many factors do we have? We have 2 of them. So I have to take my second factor and set that factor equal to 0, and then solve for x. How do I get x alone? I subtract 1 from both sides. And now how do I write this as an ordered pair? X, comma, and where did this x value come from? It came from setting y equal to 0. So I have 2 x-intercepts. Okay, so each factor gets set equal to 0 and solved for, because that's going to give me my 2 points that I could cross over the x-axis. And I shouldn't say could. They're my 2 points where I will cross over the x-axis. Okay, so let's look at one more example together. Find the values of a, b, and c. Okay. A is the number in front of my x squared term. There's no number written, so I know it to equal 1. B is the coefficient to my x term. X is being multiplied by -7. C is my constant term. My number alone with no variable is 6. All right, I'm going to factor. Since a is equal to 1, I can find 2 numbers that multiply to +6 and at the same time add to -7. I encourage you to pause the slide and find the answer for yourself. Unpause it and then check your work. -6 times -1 is +6. -6 plus -1 is -7. So my factored form, x minus 6 times x minus 1. Okay, I keep that on the next slide. Find the x and y intercepts. I'm going to find the y intercept first because that's easier. So wherever I see x, I'm going to replace my x with the number 0. So literally, wherever I saw x, I replaced it with 0. And what am I left with? I'm just left with the value of c. So what's my y-intercept? My y-intercept is the point 0, 6. Where did the 0 come from? Well, remember, ordered pairs are in the form x, y, and we made x equal to 0 before we could even start the problem. So x is equal to 0, y is equal to 6. Okay. And then lastly, find the x-intercepts. X-intercept, I always have to solve for x. This is where we use our factored form. So in my factored form, wherever I see y, I'm going to replace it with 0. And if I'm asking you to solve for x, well then I can't plug in any number for that. That's what I'm finding. Okay, so my first factor is x minus 6. This is why we use factored form. All our work's done for us. I set my factor equal to 0, and I solve for x. How do I get x alone? I add 6 to both sides. So what ordered pair is this? X is 0 because y was set, x is 6 because y was set equal to 0. So that's 1. Now I'm going to take my other factor. X minus 1 is equal to 0. I'm going to add 1 to both sides to get x alone. So my second x-intercept is 1, 0. It's very important that you can find these pieces because they're going to give us so much information about what the graph of our quadratics look like. Okay, so lastly, please attempt the March 20th check for understanding, and then I'll reassign a classwork grade for that. Thank you so much.